Hey. All right. So welcome to our first lesson for module for lesson 12. And I shouldn't say first lesson, first video for module 4, lesson 12. We're looking at comparing tables and equations. And in these lessons that we're going to be doing for this particular module or for this particular lesson, is we're going to be looking at comparing various formats of linear equations. In this case, we're looking at tables versus equations. We're also going to look at graphs versus equations and graphs versus tables. And last but not least, we're going to have a bonus video where we compare all of them in terms of like a word problem. When we look at these equations and when we compare them all, we're going to compare all of our equations to slope-intercept form. So we were going to be looking at them in terms of y equals mx plus b. Because if we can compare the slope, or essentially how fast something increases or decreases versus where it starts, we can have a pretty good idea of what is going to be happening in that equation, and we can compare which one is potentially going to, in the long run, be higher or lower. Situations like this would be one of those things where you might be looking at two quotes from a guy who's redoing tile in your living room or in your kitchen or in your bathroom or something like that. You want to figure out what's the best deal based on the amount of tile or time that he's going to be spending. He might be more expensive than another person doing the same thing. So this sort of concept, while we're going to be looking at it in a very basic way in terms of tables and equations with just numbers, we are going to be looking at them in terms of slope and y-intercept and just sort of dissecting what that means. So let's check this out. We have first this table versus this equation. If I look at this equation, it's already written in slope-intercept form. So I can very clearly see my slope, and I can very clearly see the y-intercept. In this, I can see the y-intercept pretty clearly. This 0, 6 is my y-intercept. But I'm going to have to do a little bit of work to find my slope. And that work is not going to take me very much time. But I need to look at how the y's versus the x's change. Because remember, slope is rise over run. We're changing our y values versus changing our x values. So 6 to 11, I'm increasing by 5. 11 to 16, increasing by 5. 16 to 21, again, increasing by 5. If I look at my x values, I'm increasing by 1 each time. So I can look at my slope now, rise over run, or change in y values versus change in x values. Slope, change in y values versus change in x values. Remember, we use that little triangle or that delta to show change in math and science. So we're going to look at the change in y values, which is 5 each time, and our change in x values is 1. So my slope is 5. My y-intercept is 6. So if I were to create an equation for this table, it would look like this. Y is equal to 5x plus 6. So if I were to look at each of these two scenarios, I could say that one is starting at a higher point on the y-axis, which is this one, the table, is starting at a higher point on the y-axis. But this equation here has a slope that's growing at a slightly faster rate, a 6 versus a 5. So that means in the long run, while this one starts lower, it grows faster over time. So if this were a tile guy situation, if I kept the amount of hours that I needed him to work very small, maybe this would be cheaper because he has a lower base rate to start out with. But most likely, if I have somebody working for longer, this would be a better option because while he has a higher base rate, his rate that he charges per hour is less. Either way, we can look at these rates or these slopes versus where we start in each of these and use those to, can you see my husband down there? He's such a dork. We can use those to compare tables versus equations. Ben, say hi.
Can't see anybody.
Yo, they can totally see you. Bye.